Okay, welcome back, kiddos. Now we are working with 10.1. So today with 10.1, we're going to talk about segments, lines, and measures of chords. Okay, so those are all related to a circle. Okay, so first let's start off with a tangent line. What is a tangent line? Okay, a tangent line is a line that intersects a circle in exactly one point. Exactly one point. Okay, so if we look at right over here, okay, this is a line of tangency. Okay, so this is a tangent line, and the point right over here, P, okay, that's called the point of tangency. So the point of tangency is where it crosses. Okay, so right over here, okay, point of tangency. Okay, so this line right over here that points touches just at one time is called a tangent line. Now, a line is tangent to the circle if and only if it is perpendicular to the radius. Okay, so if we look at right over here, we talked about a radius last time. Radius goes from the center to the actual circle itself. So it has to be perpendicular. It has to have this right angle, right? So that means it makes a right angle. Okay, so that's what we're talking about right over here. Okay, it has to be perpendicular. Okay, so otherwise it is not tangent. So that's the main thing. All right, so let's get right into some practice with that. So it's asking on this one right over here, is ST tangent to circle P? So ST is right over here, right in that circle P. So they're asking, is this tangent? What that means is it perpendicular? Right? And we'll use this symbol right over here to mean perpendicular. Okay, so we're asking ourselves, is this a right angle or not? Okay, we're asking ourselves, is that a right angle? So how do we find out? We're going to use the Pythagorean theorem. Okay, so here's how we're going to solve these problems. We're going to use the Pythagorean theorem. So remember, that's going to be a squared plus b squared equals c squared. So what we're going to do is we're going to ask ourselves, are these equal to each other, right? So if we take the two legs and we square them and we add them, is it equal to the longest side squared? All right, so let's look over here. Which one would be the longest side? If this was the hypotenuse, right, that would be if this was a right triangle, that would be the hypotenuse, right? So that would be right over here. So that would be that 37 squared, right? So then we're going to put the 35 and the 12 over here. So 12 squared plus 35 squared. And we're asking ourselves, are they equal? Okay, so we would just type this into our calculator right over there, right? And that would give us 1369, right? And then we would put this into our calculator. Okay? If we put that into our calculator, that would also give us 1369. Okay, so what we would do over here is we ask ourselves, are those equal to each other? Is this equal to this? Yes, it is equal to it. Okay, so that means yes, it's tangent. Okay, so that's our critical thing. Does it make a right triangle? If it does, that means this line is tangent. Okay, so we're asking if it's perpendicular. All right, so keeping that in mind, let's go and get into some another example right over here. So pause the video, see if you can get this one on your own. Okay, so it's asking, is ST tangent to this? So they're asking, is this a right angle or not, right? They're asking, is that a right triangle? So let's go ahead and set it up, right? So we're going to set up the a squared plus b squared, and we're going to compare it to the c squared, right? So which one would be the c squared? Well, this one right over here, right? Right across from there. that would be the hypotenuse, so that's going to be that 51 squared. All right, so now it's going to put that 24 and the 44 there. All right, so 24 squared plus the 44 squared. Right, and so we're going to compare it right over there. So that's what we're doing, is we're asking how is that compared. So if we put that in our calculator, right? If we put that in our calculator and we put that in our calculator, let's compare those two numbers. So this one is 2512. That's 2601. So those are not equal to each other. So no, that one is not tangent. Okay, so that's what we're doing on those. If we're trying to find out if they are tangent, that's what we're finding out. Okay, so let's take a look at this one right over here. This is going to the next level. Okay, so I know we can do this because we've been practicing up to this point. In this diagram, point PB is a point of tangency. So they're telling you that it is perpendicular. Okay, so they want us to find the radius. Okay, well, what is the radius? The radius is this right here. So if we know this is perpendicular, right, then we know that that has a right angle, right? That's what it's telling us right over here, because it tells us it's a point of tangency. So that means we can use the a squared plus b squared equals c squared, right? Because we know that's a true statement. So let's go ahead and set that up. Now, I'm going to change this to a different color so we can see that pop. All right, so this is our triangle right over here, right? So let's go ahead and set that up. What would be the value for the a squared? Okay, so that would be one leg. So that's the radius, right, from there to there. So let's just put r right over there, right? So r squared, right? Okay, then plus b squared. So if this is going to be the hypotenuse, this is going to be the b, right? So we're going to put plus 80 squared equals, now here's the tricky thing. This is the whole hypotenuse, right? It's not just 50, and it's not just r, right? It's 50 and the r, right? We got to add both of those together. So that's going to be, let's put that as r plus 50, and that whole quantity is squared, right? So hopefully that makes perfect sense to you. So the whole quantity is squared. So that's that whole side. It's not just 50, it's not just that. So now let's just go and do the math on that. So r squared, we're going to bring that down as just r squared, right? Okay, plus, now we can put this into our calculator, 80 squared. If we put that in our calculator, we know the zeros at the end are going to make 2 zeros. So 8 times 8 gives us 64. So we know that's 6,400. We can put it in our calculator otherwise. All right, now let's do this. This is r plus 50 times itself, right? So let's just kind of do that. That would be r plus 50 times r plus 50. Okay, now I know this is a little tricky, but we can definitely do this, all right? So just stick with me on this. So r plus 50. Okay, so now let's keep it going. So if we brought that down, that's r squared plus 6,400 equals, now this we probably didn't practice too much in Algebra 1, but this is, we're going to use what's called the FOIL method, F-O-I-L. So that stands for first, then outer, then inside, then last. So first, so for the F, we're going to do the first times the first. So r times r. R times r is r squared. Okay, then we're going to do O for outside. So the outside's r times 50. So r times a positive 50 is just going to be positive 50r. Okay, now we're going to do I. I stands for inside. Okay, so that's going to be the two inside ones. So r times 50, positive 50 times r is just going to be positive 50r. All right, then our last one. Last one's L for last, so that's going to be the 50 times the 50. So basically, it's just a way of multiplying all those terms together. So 50 times 50, just like we did before, we know the 0 and the 0 are going to make 2 zeros at the end, right? And then the 5 times the 5 gives us 25. So that's just a little trick that we can do when we know those zeros are at the end. All right, so I know that looks kind of crazy, but let's just follow our math. All right, so we know we're going to follow 3 steps. We're going to divide. We're going to combine our like terms. Then we're going to add the opposite if possible. Then we're going to divide, right? So 3 steps. Combine our like terms, add the opposite, and divide. So if we see over here, we have these that we can combine, right? 50r plus 50r. So that's going to be 100r, right? And then we're just going to bring that down. R squared plus, and then we have the 2500, right? And then r squared plus 6400. Okay, so let's think about what we're trying to do. We're trying to solve for r, right? So uh, if we have a r squared over here and a r squared over here, let's just move that over here, right? So we're going to subtract r squared. We're going to subtract r squared. What happens with that? That cancels out. That cancels out. Now we just have 640 equals 100r plus 2500. Right now, maybe it looks a lot easier to work with. Now we're going to subtract 2500. We're going to subtract 2500. All right. Now, if we're going to bring that down, that's going to be what does that give us? 3900, right? 3900 equals, that cancels out 100r. You might be able to do this in your head already. You may already know that we're going to divide both sides by 100. So that cancels out so that r equals, the zeros cancel out. 39 divided by 1 is 39. So that's our answer. R equals 39. So I know that was quite tricky, but it's definitely doable, right? So we just started well with our a squared plus b squared equals c squared. We set that up. We expanded that. We did all the multiplication, then we combined our like terms, and then we just solved, just like that. Okay, we're going to skip this problem right over here for right now. And now let's go ahead and look at this last theorem right over here. This is called the external tangent congruence theorem. Okay, so if this is our circle right over here, right? External means on the outside. So if we have this and it's a tangent, and this is a tangent. So if both of these are tangents, if both of those are tangents, then we know that one is congruent to the other. So RS would be congruent with TS. RS would be congruent with TS. Okay, so that means that the lengths are equal. Right? RS could be equal to TS. So congruent means the shapes are the same. Equal means the lengths are the same, right? So that means that the lengths of those two are equal. So if we're going to keep that in mind, let's do some practice right over here. Okay, so it says RS is tangent at this. Okay, so find the value of x. So if RS is tangent, RT is tangent as well. Okay, then we know that RS equals RT, right? So if they're both tangent, that means they have to be equal, right? So that means this has to be equal to that. So let's set it up. We're going to say 3x plus 4 equals 28. And then we can just solve, right? So we're going to subtract 4, so 3x equals 24. Divide both sides by 3. You may already know that x equals 8. And so all we got to do is just set it up correctly. All right, so that's the basics of it for right now on a tangent. Okay, so a tangent line just means that it crosses exactly at a 90-degree angle. So if we want to know if it is tangent, we're going to use our Pythagorean theorem. If they're both equal, then it is tangent. If it's not, it's not. And then sometimes we have to do what's called a polynomial. All right, so let's go ahead and do those practices in Delta Math before we move on to the next page. Okay, kiddos, so now we're going to talk about central angles and arcs. All right, so let's go ahead and look right over here. All right, central angle. What's a central angle? Okay, so a central angle is this right over here. It's an angle whose vertex is on the center of an angle, of a circle. So if we see this right over here, this is the center. So this right over here would be a central angle. So let's go and trace that out. So if we went from A to C to B, okay, so we would call that angle ACB. Okay, and it's equal to, this tells us right over here, that's equal to 50 degrees. So that one in particular is equal to 50 degrees. All right, so that's what we call a central angle because the vertex is in the center. And the sum of all the central angles of a circle, so if we added those all the way around, that would be equal to 360 degrees. Okay, so all the way around is 360. Now, if we look at this right over here, this curve is called an arc. Okay, so this is called arc AB. All right, so that's what we use, is we use this symbol right over here that means arc. So the arc is what is created by that central angle. And so this right over here is created by that central angle. So let's go ahead and investigate that going forward. So we have what's called a minor arc, a major arc, and a semicircle. And it depends on how large that is. So minor, you would think is smaller than a major. So a minor arc is going to be less than 180 degrees. Let me clean that up. Okay, so less than 180 degrees. That's going to be minor. Okay, so a minor one, we're going to use two endpoints. Okay, so if we look over here, this is going right through the center. We say the whole thing is 360. So this one right over here, RP, would be one of our small ones right over here. That would be RP. So it would be RP. Okay, and we're going to use that right there for an arc symbol. Okay, and then we have another one right over here, right? PM, right? And those are created by those central angles, excuse me. So this angle right over here created that arc. This angle right over here created that arc. So let's call that one PM. So PM. So those are the two on there. All right, so that one's going to be minor arc is when it is less than 180 degrees. All right, so then that's a minor one. So now let's talk about a major arc. So major, you would think is going to be bigger than a minor. So a major arc is greater than 180 degrees. Okay, so that's a major arc. Now with this one, we're going to use two endpoints and a point on the arc. So that's going to use 3 letters. Okay, so this one has 2 letters. Okay, so that's how we can kind of tell between the two of these. This one we can tell because it only has 2 letters. It has to be a small one, less than 180 degrees. So now this one is greater than 180. So let's look. RP, that's smaller than 180, right? That is exactly 180. Because halfway would be 180. So if we went from RP all the way over here to N, right? Just imagine that. If I went all the way over here, that would be a major arc. And I would call, it says use 2 endpoints and a point on the arc. So I know it's going to be R and N on the outside, but I can call it RPN. So I can say RPN. Okay? Or I can also have, I can go this way. I can go RN to P, right? So let me change it to a different color. So I can say R all the way to N, go through M all the way to P. So that would be RNP. Okay, so that would be a different arc. So those are major arcs. And there's actually a couple more that we could use on that too, but those are 2. So major arcs, which are greater than 180 degrees, we're going to use 3 letters. Okay, so then a minor arc is less than 180 degrees, like that, we're going to use 2 letters. Now a semicircle is exactly 180 degrees. So a semicircle goes through the center because it's created by a diameter. So it uses 2 endpoints and a point on the arc. So RPM, right? So this would be a semicircle. So 2 points and a point on the arc. So RPM, right? Now also we can think about this one right over here, right? That's also a semicircle. We know it's a semicircle because it goes through a diameter right over there, right? So we call that one RNM. RNM. Okay, so those are our arcs: minor arc, major arc, and semicircle. So if it's less than half, right, less than 180, it's minor. If it's more than half, then it's a major. And if it's exactly half, that means semicircle. All right, so keeping that in mind, let's get into some arc addition. So we know our addition postulate, right? So our additional postulate says a part plus part equals whole, right? Part plus part equals whole. We can remember part plus part equals whole. So let's look over here. It says measure of angle, I'm sorry, arc. That's supposed to be arc ABC. So ABC, right? So A to B to C. We could say that's going to be equal to AB plus BC, right? So arc AB plus arc BC, right? If we added AB plus BC, it would equal a whole thing. So that's our arc addition postulate. All right, so thinking about that, let's get right into some practice right over here. Okay, so it says find the measure of each of these arcs. Okay, then determine if it's a major, minor, or semicircle. Okay, so GHE. GHE. Let's go ahead and trace that one out. GHE. Okay, I can already tell that one's going to be a minor, right? Because it's less than 180 degrees, right? So that one is a minor one. Now, what do we know? GHE is going to be this. It's going to be equal to GH, right, plus HE, right? GH plus HE. Well, how much is GH? GH is 26, right? So we'd say that's going to be 26 degrees plus HE, right, which is 78 degrees, right? It tells us right over there. That one's 26 and that one's 78, right? So all we have to do is just add those together, right? So if we put that in our calculator, 26 plus 78, that's going to give us 104 degrees. Okay, so 104 degrees means it's minor because it is less than 180, right? Just like we talked about. Minor means it's less than 180. All right, so let's keep it going. So let's look at HEF. HEF. Let's go ahead and kind of trace that one out. HEF. Let's use a different color. HEF. All right, so that, if we look at it, that's not a diameter, right? It doesn't go from one side directly through the center to the other side on the other side, right? So that one's going to be a minor one as well, right? We know that's going to be minor. All right, but HEF is going to be equal to HE plus EF, right? That's going to be HE plus EF, right? So that's going to be equal to 78 plus 95. Right? And so that's going to be equal to 173 degrees. Okay, so that's all we're doing is that we're just adding those together. So now let's look at this last one. EFG. E, F, and G. Well, what do we know about that? EFG. Let's kind of trace that out. And use a different color on that one. So EFG, EF, all the way over to G, right? What do we know about that? The whole thing is 360, right? So we know how much this is, but we don't know how much this is straight away, right? We could calculate it how? Let's think about this. If we knew how much this is, right? Think of it like pizza, right? So if we take out this part of pizza, the whole thing is left, right? So the whole thing is 360, right? So let's figure that out. So we said that's going to be equal to 360 degrees minus this part right here, right? So if we subtract out that, which we said that's going from GHE we said was 104, right? So subtract out that 104, and that has to be what's left, right? So if we did that, 360 minus 104 gives us 286 degrees. Okay, so that's our answer. How much is 286? That is a major, right? Major arc. All right, so that's what we're going to keep in mind on that one, is that we're just going to do our arc addition. So thinking about that, let's go ahead and do this higher level one using algebra. All right, so it says find the value of x, then find the measure of AB. Okay, so x, if we look over here, what they're saying is this represents this arc right over here. Okay, well, if we need to solve for x, that means we need to make some sort of equation involving x, right? Well, what do we know? We know all these measures These are all measures on the outside, right? So this is from here to here, right? This is from there to there, then that's from there to there, and then this is from there to there. So what we do know is all these add up to how much? That's right, 360 degrees. So let's set it up. So 5x plus 40 plus 70 plus 75 plus 2x. Right? We said all these add up to 360 because those are the measurements, right? Now, one thing is I dropped the parentheses because we're adding, we don't need the parentheses. So what do? We said the first step is combine, right, like terms, then we're going to add the opposite and then divide, right? Those are our three terms. So let's combine. So we're going to say 5x, right, plus 2x. 5x plus 2x gives us 7x, right? Then we're going to say 40 plus 70 plus 75, right? So that's going to be 185. Okay, that's going to be equal to 360. All right, so if we subtract 185 over there, subtract 185 over there, it cancels out 7x equals 175, right? So if you divide both sides by 7, cancel out x equals 25, right? But if x equals 20, so find the value of x, right? So we got x equals 25. Then find the measure of AB. Okay, we said AB is 5x. All right, so AB is equal to 5x, which is equal to 5 times 25, which is equal to, right? Because that's where we got that 25. That's where we got that 25 from, right? So that's what we're going to put over there. So 5 times 25 is 125. So those are our two answers. X equals 25 and 125. All right, so let's talk about this last part. Congruent circles. Okay, so two circles are congruent if and only if they have the same radius. Right, so if I have this over here and I have this over here, if this radius, say, is 3, right, and this radius, say, is 4, then no, they're not congruent. Right, but say I have this one right over here, right? So if this one was 4, right, and this one was 4, then yes, they would be congruent. Okay, so they are only congruent if they have the same radius. All right, now congruent arcs. Two arcs are congruent if and only if they have the same measure, right? So we're talking about arcs, right? Same measure and they're on the same circle or congruent circles. So they have to be both of those, have the same measure and either on the same circle or congruent circle. So let's talk about these last problems. I know we can get this. It's a little tricky, but we got this. All right, determine whether the arcs are congruent. C, D, and EF. C, D, and EF. Pause the video. What do you think about that? Okay, so C, D, and EF. Well, we said they're the measures of the central angle. So if this central angle is 80, and this central angle is 80, that means they are congruent. So we would say yes, because both have the same measure and on the same circle. Okay, so that's what we said. Two arcs are congruent if and only if they're the same measure and they're on the same circle or congruent circle. So the same circle and the same measure. Now RS and TU. RS and TU. Let's take a look at that. RS, right? RS is just right over here. That's created by this angle, right? And this angle is 90 degrees. So that means RS is equal to 90 degrees, right? Well, how about TU? TU is also 90 degrees, right? Because they both are created by that 90 degree angle, right? That one and that 90 degree. So are they congruent? They're both the same measure, but the answer is no, because not on the same circle. Right? These are on two different circles. That's one circle right there. That's a different circle right there. We said they have to be on the same circle or congruent circles. These are not congruent. All right, so that's it on this lesson right over here. I know we went through a lot of tricky concepts, but the arc is what is created by that central angle. So this is a central angle here. If that's 50, that means that arc is also 50. They all add up to 360. If it's less than 180, it's a minor arc. If it's greater than 180, it's a major arc. And if it's exactly 180, it's a semicircle. And we just remember our part plus part equals our whole.